Make sure it starts correctly. Right, good. All right. Balancing chemical equations. So let's do this one together. Read your instructions on this. We need to show our work. We need to show our work, and I'm going to show you my work. And again, I'm going to do it with you. As I said yesterday, I think it was yesterday, Wednesday, sometimes there are just things that are easier to do on paper and pencil. And again, I use math as an example. Sometimes math is just easier when you're able to write stuff down. Planning, grocery shopping, sometimes it's just easier when you write stuff down and you take the list to the store and you can cross it off. It's sometimes just easier. Yes, you can make a list on your cell phone. Yes, you can delete it or whatever, but sometimes it's just easier just to done, check. You know what I mean? Chemistry, sometimes it's just easier to do it by hand on paper and pencil when it comes to balancing chemical equations, especially when they're not impossible. They'll never be impossible. But sometimes they get a little weird, they get a little crazy when it comes to balancing. Okay? And that's just the reality of it. Not all chemical reactions are simple and easy. So the first 4 questions are review from our notes on Wednesday, which I know I went very quickly through. I'll let you take a look at that. But I want to do some practice with you. And I want to actually show the handwritten practice. And I did a lot of this yesterday with the kids, but today we're all going to do it for real. And we're all going to practice writing out equations and doing what's called the inventory method. So let's get rid of this. So it says on here in the instruction, for the following problems on a piece of paper, handwrite to complete the inventory method to balance each chemical equation. Upload a picture of your work below. You will not get full credit without showing your work. So you're going to put a picture of your work down here. Okay? Now, question number 10 is a little bit more of a challenge question, but you can probably figure that one out too. All right, so let's show it work for aluminum bromide and potassium, making potassium bromide and aluminum. We did one very similar to that yesterday. So, go ahead and write it out. Aluminum bromide plus potassium. Going to make potassium bromide plus aluminum. And again, these formulas I'm writing, like I know what the formulas are because I've been doing this long enough, but you can figure out those formulas. Aluminum has 3 valence electrons. Bromine has 7 valence electrons, right? I'm going to send one there. Well, I need another bromine. I'm going to send one there. And I need another bromine. Because it has 7 valence electrons. So the formula is AlBr3. So again, it's not like somebody just making up these formulas. These are the chemical formulas for these guys. Not gonna do that. Anyway. All right, so anyway, let's do the inventory method then. So again, hopefully everybody has a piece of paper. We're all gonna do this right now. We're all gonna get credit. We're all just practicing. So inventory method, I want my count on the left and right. So let's just all do this right now. Do what I'm doing. Aluminum. How many aluminum do I have on the left? Shout it out. Yeah, how many aluminum on the right? That's easy. That's done. I don't need to do anything with aluminum. Right? It's finished. It's easy. Bromine, how many on the left? How many on the right? Okay, that's not right. That I have to do something there, right? And then potassium, how many on the left? How many on the right? Okay, so this is a very easy problem because everything's balanced except for one thing. Now, when we go to fix that one thing, it might ruin everything else, okay? But I'm not going to do anything with aluminum. I'm not going to do anything with potassium. They're already balanced. So I have to fix the bromine. And it's all multiplication. Remember? So again, I wish I could go over here and just stick a little 3 on there. That'd be awesome. I'll be done. But again, that's not the formula for potassium bromide. You, again, draw it. You're not going to get 3 bromines on there. Okay? So again, you can't do that. That would be too easy. So what we have to do instead is we need to multiply this bromine by 3 in order to get 3. So that means I got to put a 3 in front of the bromine, which is up here. Now that messes up my potassium. How many potassium do I have now? So I'm gonna show my work. I'm gonna cross out the 1, and I'm gonna put a 3 there for potassium. Now I have 3 of them. Aluminum's still good. I don't need to do anything with aluminum. Okay, so now I got to fix potassium. I have 3 on this side, 1 on this side. So again, I'm going to multiply by 3 in order to get 3 potassium. So I'm going to put that 3 in front of the potassium. Done. Okay, that did not mess up anything else, which is good because aluminum is balanced 1 and 1, bromine is balanced 3 and 3, and potassium is balanced 3 and 3. Now on both the Chem Balancer and on Canvas, we want to go ahead and practice putting a 1 in front of these here. In real life, we don't need to put a 1 in front of those because I know there's 1 because I wrote the letter. If there wasn't 1, I would not write that letter on there. Okay, so we don't have to write the 1, but we do want to kind of maybe go ahead and get a little bit of practice on that. Yeah, so this is the inventory method. Yep. Yeah, so go ahead and actually show your work for today. Eventually, someday, you will be good enough to do these in your head. Now, granted, I know that was an easy one. You could probably do that one in your head. But trust me, 14 years of experience and then 7 years of college experience before that. Kids make a lot of mistakes when they try to do stuff in their head. Sometimes it is just easier to do it on paper and show your work. So I'm going to ask you to show your work today, which I already did. That's number 1. So there's your answer for number 1. So let's go back to the worksheet. Let's type in 1331. So I'll go back to worksheet 1, 3, 3, 1. Okay, and there's my answer. And we'll put the picture later. Okay, I'm going to erase this so that some of you guys don't steal my work. All right, well, that is the answer for number 1. All right, number 2. Okay. And you might have looked at number 2 yet? Yeah, number 2 is already balanced. Let's just go ahead and show our work, though. All you gotta do is just write it out and calculate it, and just double check it. Yes, I did it by looking at my eyes. I can tell, but so again. So number 2, the iron oxide. It was the iron oxide, palladium chloride 2. And that is going to make iron chloride 2. That would not make that. Oh yeah, it would. Oh yeah. So iron F2. Okay, all right, that makes sense. I like that. All right, so inventory method, real quick. Iron, how many on the left? How many on the right? How many oxygen on the left? How many oxygen on the right? How many palladium on the left? How many palladium on the right? How many fluorines on the left? How many fluorines on the right? It's all done, okay? Now, if this shows up on Canvas, what we would need to do is go ahead and put a 1 in all of these spots, okay? Just to make it right. So go ahead and do that on your worksheet too. Go ahead and put a 1 in all those spots. All right, well that was a little too easy. I don't even know why that's on the worksheet. Number 3, pretty easy. I won't worry about that one. Number 4 is super easy, so number 5 is real easy. All right, let's do number 6. Number 6 gets a little bit trickier. It's not impossible, pretty easy, but actually, yeah, number 6 is actually pretty easy. But anyway, but there's a trick for number 6. So number 6 is cobalt, bromide, calcium sulfate. Cobalt, bromide, plus calcium sulfate is going to make calcium bromide plus cobalt 2 sulfate 3. Double check my work. I think that's what it is. Yep. Okay, good. All right. Okay, now inventory on this one. Again, go ahead and do it with me. This is number 6, so give yourself a little bit of room for the other one. Let's just go ahead and start with cobalt. How many cobalts on the left? How many cobalt on the right? 2. Bromine, how many on the left? How many bromine on the right? 2, that's it. All right, calcium, how many on the left? 1. How many on the right? Okay, calcium done. Now, for sulfate, I could write S and O separately. It doesn't matter, I'll get the same answer. But a little trick is that I could write SO4 on the left and SO4 on the right. Because I have sulfate, SO4 on the left, and I have sulfate on the right. So I can just keep them together. So I could just say, how many SO4s do I have on the left? I have 1. I have 1 SO4 on the left, and then how many SO4s on the right? I have 3. Now, that I could also, instead of saying that, I could also say this. I can also say this as well. That's the same thing. Okay? So it doesn't really matter how you do that. It's just a little bit of a trick. And I will be honest, when it gets difficult, it is nice to have that trick in place so you don't have to worry about your parentheses and all that jazz. All right. 1 to 1, we don't need to do anything with that. 3 to 2. That is kind of a weird multiplier. That would be a 1.5 multiplier, right? That's kind of weird. We don't want to get half stuff, so let's wait. Let's wait and do that one last. But we have a 1 to 2 multiplier. That's super easy. And we have a 1 to 3 multiplier. That's super easy. So it doesn't really matter which one you want to do. Let's just do the easiest one here. This just means multiply by 2 on that one, right? To give me 2. So I'm going to put this 2 in front of the cobalt, because that's what that means. And that gives me 2 cobalt. But that changes my bromine, my Br. How many do I have now? I have 3 on the formula, times 2, give me 6. Now look at that 2 to 6 ratio. That's easier multiplier now, right? That just means times 3 over here. Okay. It doesn't matter if you want to do that one next, but we could do that if you want. So, what you guys want to do next? You guys want to do the bromine? You guys want to do the sulfate? Want to do bromine next? All right, so this bromine, we're going to multiply this one by 3, what we just said, or make that 6. So this 6 is going to go in front of the bromine. Oh, no, sorry, I messed up. Not 6, 3. This 3 that we multiplied is going to go in front. of the calcium bromide, and that gives me 6. And then that changes my calcium. Now I have 3 calcium. Okay. So look, I got 3 and 3, 1 and 1. Pretty easy multiplier here. I'm going to multiply this one by 3. I'm going to put a 3 out front. That also tells me now I have 3 SO4s as well. And then everything is balanced here. 2, 3, 3. And then we're going to put a 1 over here in that blank for that. All right, so again, it's just, sometimes it's just easier to follow the math, keep it all together so that we're not really, we're not just losing stuff in our brain and our mind. Now again, I know some of you are fancy pants and some of you are super duper smart and you will never make a mistake. I know that, okay? But sometimes simple, easy, silly mistakes are made because kids just don't keep track of the math. Even myself, just like that 6 I wrote up there, sometimes I mess myself up. And if I don't catch myself, I'll be like, it never balances, why not? Well, because I made a simple mistake on there. And I will say that too, just as a heads up for anybody. If you can never balance the equation, no matter what you do, you probably made a mistake somewhere. Because every chemical equation will balance out if it's a real chemical equation. Okay? So if you can never balance it out, you might want to just start over and try again to balance them. All right. Do you want me to do another one, or you want me just to be quiet and let you guys do it? Any particular number if you want me to do it? That one is really easy. I tell you what, let's take a look at number 8. Katrina, you might be able to help on this one. We talked about this one. We talked about one similar to this yesterday. Yeah, let's take a look at number 8. Number 8 is a little tricky. Let me check my email real quick. I need something here. Nope. Okay. All right. It says manganese, hydrogen iodide. I like this reaction, by the way. This reaction is a kind of a cool reaction. All right. This one is going to require a little bit of work. So let's just go ahead and do this one together. It's literally the hardest one on there, and I'm going to give you the answer. But anyway, let's go ahead and show the inventory. Number 8, I believe. Yep, number 8. All right, how many manganese on the left? There's 1 on there. How many manganese on the right? 1 on the right. You see that? How many hydrogen on the left? 1. How many hydrogen on the right? 2. How many iodides on the left? How many iodides on the right? 3. This one, we're going to get into, we never want to use fractions, so this one's going to be a little bit weird here. Okay. All right, so we want to start off with hydrogen or iodide? It doesn't really matter. We're going to have to do something weird in a second anyways. You want to do the iodide? All right, so let's change it to iodide. Let's multiply this by 3 to get me 3 iodides. 3 is going to go up there. All right, and that messes up my hydrogen. I now have 3 hydrogen. So, how do I go from 2 to 3? So, we were kind of have to do like a 1.5, right? Kind of do a 1.5. That's not a really friendly number there. That's a fraction, 1.5. So, Katrina, remember what we did yesterday? What do you recommend doing? So you can set those equal to 6. And what that means is you're doubling everything. So what if we doubled everything? So let's double this to 2. Let's double this to 6. Okay, that will double that to 6. What if we double this one to 4? And we double this one to 2, and double this one to 6. Okay? So when we double everything, then we have a new spot right here. Can you guys see yellow, okay? Yeah, you can see yellow, okay? All right. Let's see here. Well, okay, that's the one we're going to fix. So I didn't double my hydrogens yet because instead of doubling my hydrogen, I mean, it was double. It was 1.5. So what is 1.5 doubled? 3, right? The 1.5 is double 3. So I can put a 3 there, and that will give me my 6. And so that is doubling. So yeah, sorry, that was my fault. I put a 2 in there, but it used to be 1.5. If I double that, that gives me a nice whole number. Now this is the same ratio as 1 to 6. This is the same ratio as, did it wrong again. As this. They are technically the same thing. Okay? It's just in chemical reaction, we don't really like using half, or decimals or whatever else, but they are essentially the same thing, it's the same ratio there. So if you don't like that decimal there, just double everything until you get a whole number. If you end up with something like 1.33, triple it until you get a whole number there. But that is an option there that you can just double everything, double all the ingredients until you get a nice round whole number. So the final answer there will be 2, 6, 3, 2 in those blanks. And again, that's a little tricky, but it's not impossible. Okay, I want to walk you through the word problem number 10, but I'm not going to balance it. Okay, I just want to walk you through number 10 just at practice. I'm going to get to the point where you guys can at least get the formulas so that we don't have to, because then you can balance it. So let's go to number 10 real quick. The word problem, it said magnesium oxide reacts with sodium nitride. All right, besides memorization, how do we figure out the formula for magnesium oxide? Draw it. Always draw them, right? Draw. Don't try to memorize. So magnesium has 2 valence electrons. It's in column 2. Oxygen has 6 valence electrons. It's in column 1, 2, skip a few, 6. Oh, everybody's happy. So the formula is MgO. Okay? We're going to add that to sodium nitride. Sodium is Na, 1 dot, it's in the first column. Nitride, 5 dots, it's in the fifth column. So I need another sodium. I need another sodium. So the formula there is Na3N1. Okay. So it says it's going to make. I even gave you the answer. I made that one even easier for you. But anyway, this is a double replacement reaction. These two metals are going to switch places. Never going to put a metal with a metal. They don't like bonding with each other, so you're going to switch places. But anyway, we're going to make magnesium nitride and sodium oxide. And again, let's just draw it. Magnesium had 2 dots. Nitrogen had 5 dots. I need another magnesium, 2 dots. Well, I need another sodium to make the magnesium happy. I need another magnesium to make that sodium happy. Okay, now everybody's happy. So the formula is Mg2N3. Again, just by drawing. And then the sodium oxide, Na with 1 dot, oxygen with 6 dots. I need another sodium. My formula there is Na2O. So your job now, that I kind of help you out with your word problem, and yes, you might see some of these, is now I want you to balance it. And I'm going to let you do that by yourself. So now that you have the formula, do the inventory method, then balance it from there. To be honest, it's a really simple, pretty easy balancer. All right, I'm going to leave this up so you guys can look at number 10. Your work for today, do a little bit of practice. And
Mr. Fan,
yep.
your numbers for magnesium nitride don't match your picture.
Say, what was that again?
Your numbers for magnesium nitride don't match the picture. You have 2 magnesiums and 2 nitrogens.
Yep, I got my nitrogen and my magnesium backwards. Yep, sorry about that. Thank you. That would make it really hard to balance. 3 magnesium and 2 nitrogen. Yep. That makes sense for the charges anyway. Nitrogen -3 charge, magnesium +2. So yep, perfect. All right, virtual kids. I'm sorry. I have a little toy for the in-person kids to play with today. But I'll play with one of them in front of you guys so you guys can watch too. But I got some whack-a-mole Easter balloon for you guys. A whack-a-pack, it's called. And these are chemical reactions. You can read the instructions if you want to go ahead and do it. All right, so these are little Easter balloons. They're called whack-a-pack balloons for Easter. And they have stuff on the inside. We'll look at it in a minute. But what you got to do is they're not mixed together right now. And so in order to mix these chemicals together, you have to whack-a-pack. You have to pop it and get the chemicals to mix together. And the chemicals start to mix together. And then, come on, get out of here. There's a balloon that pops out. Not pop. Oh, it popped in my hand. And then a balloon popped out of the bag. And they're chemicals that are mixing together to create a gas, which this is the exact same lab you did. Yeah, this is the exact same lab you guys did on Monday and Tuesday. Yep, forming the gases on them. Okay. Now, if you cut it open, where my scissors are. And you guys don't have to cut it open, but you can. Now, let me make my screen a little bigger for you guys at home. But if you cut these open, you will see. I don't know if you guys can see very well, but there's a little plastic ball. Little plastic bag, and the chemicals are still in there. Okay. So there's a little plastic container that has the liquid in it, and then that's what you broke. You smashed the liquid, and then the liquid went on the inside where all the chemicals are, and the liquid takes the chemicals straight out. This is essentially, you know, if you ever made a volcano out of chemicals, oh, Karen there for a second. Well, this is basically, you know, I believe it's an acid called citric acid, and it's reacting with sodium hydroxide to create carbon dioxide gas in there. And you got yourself a little balloon. If you want a little holder for your balloon, I got little string up here. I got a bunch of them if you want one of those up there. All right, so for today, a couple practice problems. Just try to turn those in when you can. I think I gave it to you on Sunday, but again, I took my time showing you all this stuff. A lot of them are pretty easy. You can balance them pretty quickly. That's a single replacement. And the one below that, yeah, common. Both of them. That's fine. Oh, they got sub. I thought Miss Dees was here today.
This machine. See it.
There's a lot of nasty stuff on the inside if you pop it. So,
That's what I'm saying inside the sink.
but I mean, yeah, if you want, or if you just want to throw it away, you can throw it away.
No,
But
I'll just
I mean, it's gonna be kind of nasty. But yeah, I guess you can do it. All right, guys, gals. Have a great day. Have a great weekend. And I'll see you guys Monday. 5-day week.